Okay, chapter 10, day 2 video. What we're going to focus on today is what are the trig identities and how do we simplify trig functions by using them. And so an identity is kind of like an equivalent relationship for trig functions. And so this whole day is going to be on rewriting trig functions using sines and cosines and their trig identity relationships to try to simplify trig expressions. So first of all, we have some identities that we know. For example, secant theta is 1 over cos. That's actually a trig identity. It's called a reciprocal identity, but it's a trig identity, and they're just equivalent. And so these are equivalent relationships. Your identities are some equivalent relationships. So here's all the reciprocal ones that we started out with around sine, cosine, and tangent, and cotangent. Now cotangent you can write as 1 over tangent, but I think you're going to see this form a lot. Cotangent theta is cosine over sine. Tangent is sine over cos. So when we work with trig identities, when we work with cotangent, I think we're going to write cosine over sine a lot more than we would write 1 over tangent. Not that we're not going to use this, but I think you have to keep this in the back of your mind as something that we're going to use more frequently. Some more trig identities. Well, here's one that's used a lot. Again, if I draw a triangle in the unit circle, okay, radius of 1, we know that the y value will take on the sine of whatever the angle is, and the x value will take on the cosine of whatever the angle is. And if we remember Pythagorean theorem, we know that sine squared plus cosine squared then would equal 1. And that is, well, these are called Pythagorean identities. And so the biggest one that we start out with is sine squared plus cosine squared is 1. And it comes from our unit circle triangle. There's 2 more that come off of that. If I subtract sine squared and solve for cosine squared, I get cosine squared as 1 minus sine squared. Or if I subtract cosine squared, I can say that sine squared is 1 minus cosine squared. So these 2 are little offshoots of this first one. These 3 are used frequently with trig identities. Keeping in mind the same type of relationship with Pythagorean relationships, we have 2 more that you just need to know. 1 plus tan squared is secant squared, and cotangent squared plus 1 is cosecant squared. So those are 2 more identities that you need to know. So, when we think about the focus today, what are the trig identities? Here they are. And how do we simplify trig functions? Let's look at what that looks like next. So for example, you might see a problem that says, write in terms of sine and cos and express in simplest form. Or you might see the directions just say simplify. I'm kind of leading you on this first one. Write in terms of sine and cos and express in simplest form. So let's start out. Cotangent. Well, it's not going to do me any good to write this as 1 over tangent. I need to write it in terms of sine and cosine. So I'm going to write cotangent as cosine theta over sine theta. Implied multiplication here. Secant theta, that's 1 over cosine theta. So now we have to remember our rules for fractions. When we multiply, if there's anything on the top that's the same as anything on the bottom, we can reduce these. Okay? Cos goes into cos once, cosine goes into cosine once, and we're left with 1 over sine theta. Now, if I want it in simplest form, I probably should rewrite 1 over sine theta as cosecant theta, and that would be my answer. So it's just about simplifying trig relationships by rewriting it in terms of sine and cos. Notice all of these up here are written mostly in terms of sine and cosine. Okay? Here's another one. Let's try secant theta over tangent theta. Well, I know that secant theta is 1 over cos theta. Tan theta is sine theta over cos theta. Well, here we are with a complex fraction again. The process doesn't change whether we're dealing with trig functions or whether we're dealing with x's and a's and b's and numbers. What's my common denominator? Cosine. So I'm going to take that common denominator and I'm going to write it next to every numerator. Cos theta, cos theta. So then this cos theta and this cos theta will reduce. This cos theta and this cos theta reduces. And I'm left with 1 over sine theta, which I know is cosecant theta. And that's just coincidence that they both turn out to be cosecant theta. What's important to know is that you just rewrite things in terms of sine and cosine, and then reduce with the same rules that you know about complex fractions or any other type of work with fractions, whether it's multiplying straight across, okay, or working with complex. But that's it. We're just going to do a lot of problems in class to see a bunch of different types of trig identity questions.